Hi everyone and welcome back to another video. In this video, we are discussing class 10th science chapter 12 electricity. So in this chapter, we will learn what is electricity, how is it flow through a circuit and what are the effect of electricity, what are the facts controlling or regulating electricity. So without wasting time, let's start. From the very beginning, electricity could surprise the people. Even they didn't understand what is electricity, they had the experience of electric shock. So they considered this one as a wonder. But some people were so curious about electricity. They were so curious about what happening behind electricity. Out of those enthusiastic persons, we cannot forget two of them. First one, Stephen Gray. In 18th century, Stephen Gray also were interested in the studies related to electricity. During one of his experiments, he noticed that some materials can conduct electricity or some materials can transfer electric charge from one material to another material. Such materials he called conductors. At the same time, some materials cannot do this. Such materials he called insulators. So, according to Stephen Gray, there are two kind of materials. First one, conductors, second one, insulators. Conductors, the materials which can conduct electricity, and insulators, the materials that cannot conduct electricity. Now, let's look into conductors. Majority of the conductors present in the nature are metals. Then here arises one question. Why metals conduct electricity? Metals conduct electricity because it has a lot of free electron in it. These free electron can easily travel through the metal lattice. Then it will contribute a flow of charge, then that is called electric current. Then how metals can contribute this much free electron? Here comes the reason. For example, let's consider a magnesium atom. Atomic number is 12. Which means there are 12 protons and 12 electrons. These all protons are situating inside the nucleus and all the electrons are around the nucleus and moving through the shells. In the outermost shell, there are 2 electrons. These all electrons are remaining in the shell because of the attractive force of protons present inside the nucleus. Because protons are positively charged, electrons are negatively charged. Positive particles can attract the negative particle. So, because of this heavy positive charge at the nucleus, these electrons revolve around the nucleus. Okay, it will not go out of that. But out of this 12 electron, some electron, which means the electron in the outermost shell. The electron in the outermost shell is far away from the center. It is too much away from the center. So, the attractive force of nucleus on these electrons are very less. So, these electrons can easily jump out of the atom. Then these electrons are free. So, these free electrons can move through the metal lattice. So, like this, metals can contribute free electrons. That's why metals can conduct electricity. Then insulators. Insulators, the materials like plastic, paper, all these things cannot conduct electricity. So that are all about conductors and insulators. Now here comes the second person, that is Benjamin Franklin. In the same 18th century, Benjamin Franklin also were engaged in the experiment related to electricity. One night he took a kite and the string of the kite he made with a conducting wire and he let the kite fly on the sky during a heavy lightning day. He considered the lighting energy as an electric energy. During this experiment, he understood that electric energy is always flowing from higher concentration to lower concentration. This higher concentration that he considered as positive and lower concentration that he considered as negative. So the conclusion was electric energy is always flowing from positive to negative. So here comes our second point. Electric energy or electricity or electric current is always flowing from positive to negative. Remember, all these are happening in 18th century. In that time, electrons were really ignorant because J.J. Thomson inventing electrons in 19th century. Those people didn't have any idea about electrons. So that's why they consider, or conventionally they considered, electricity is the flow of positive particles or positive charge. Also, the direction of electric current is always from positive to negative. So, this is too important to remember. In every circuit, the direction of electric current is always from positive to negative. Electricity is always flowing from positive to negative in a circuit. Electrons are always flowing from negative to positive. So, the direction of electric current is always opposite to the direction of electrons flow. Now, let's look into electric current. What is electric current? Electric current is the amount of charge flow through a particular area in unit time, or in other words, we can say that it is the rate of flow of electric charge, which means I is equal to Q by T. I is equal to Q by T. I indicating the current, Q is for charge, and T. About the unit of these quantities. First one, about electric current. Electric current, its unit is ampere. It's represented by capital letter A. And electric charge, its unit is coulomb. It is represented by capital letter C. Next one, unit of time, that you know, you are familiar, that is seconds. So these are the SI unit. Okay, so let's discuss about this. Consider a conducting material. Okay, so we have a conducting material here. So this is a conducting material. It can be a metallic piece. Okay, so because we said majority conductors are metals, so here we have a metallic conductor. So in this metallic conductor, so there will be many atoms, right? So let's imagine these are atoms. Okay, so these indicating atoms. There are many atoms are there. If it is a iron rod, so these are the atoms of iron. And just before we said these atoms can produce free electrons. We took the example of magnesium. Similar manner, these atoms can produce free electrons. So these free electrons can move through this. Suppose this atom. Okay, so this atom here, equal number of protons are there, equal number of electrons are there. Imagine one electron is jumped out. So this yellow one is the electron jumping out of this atom. Then what is the charge of this atom? So this charge atom get a positive charge. Let's mark it by another color. Okay, it will get a positive color. Now similarly, look at another one. Similar manner, one more here, one more is producing here, right? So this one will become positive charge. This is negative charge. And similarly, that many are producing the same. So here electrons are jumping out. Now here the charge is positive, and here similar, here one electron is jumping out. Okay, and producing their positive. Okay, positive. Similar here one positive, and here one electron is coming out, and here one positive, and electron is coming out. Look at this, most of the atoms could produce free electrons, but some atoms still remaining neutral because they are not providing any free electrons here. So in a conductor there are three kind of particles. First one, there are atoms. Okay, because chargeless atoms, this is neutral, there is no charge for that. Second one, electrons. Charge of electron is negative, that we know. And another one is this positive charge. After liberating electron, the atoms would change to positive charge particles. These charged particles are called ions. So these are positively charged ions. So these all are the particles present inside a conductor. Now these charges, okay, so these electrons are negatively charged particles. If these negatively charged particles, if these particles move in one direction, one single direction, then we can call that one as electric current. These yellow color, that is electrons. Okay, these electrons are, imagine all these electrons are moving in one direction. According to our definition, we said that electric current is the flow of charges. So here these negative charges are flowing in, imagine, okay, it is flowing in one direction. Now a simple metallic surface, if you consider, the electrons are not flowing in same direction. These electrons will move here and there. It will be all the electrons will move in different direction. Then how these electrons are moving in same direction, that we can discuss later, okay. For this instant, just imagine these electrons are moving in one direction, okay. So this, if these electrons are flowing one direction, flow of charge is there, then it can constitute a electric current, okay. So this electric current that we can calculate by I is equal to Q by T. Then look at this Q. Q, we said this is the electric charge, net charge, total charge. Here charge particle is electrons. So all the electrons are moving in one direction, which means the total charge is depending upon the count of free electrons. Here one electron, charge of one electron, okay, charge of one electron, that is 1.6 into 10 raised to minus 19 coulomb. 1.6 into 10 raised to minus 19 coulomb is the charge of one electron. Okay, so the total charge, how you will calculate? If there is one electron, then the total charge Q is 1.6 into 10 to the power minus 19 coulomb. 10 electron, then total charge Q will be 10 into 1.6 into 10 to the power minus 9 coulomb. Right, because 10 electrons are there. One electron has a charge 1.6 into 10 raised to minus 90. So similar manner, if there is 100 electron, then 100 into 1.6 into 10 raised to minus 19 coulomb charge will be there. So let's imagine that there are n electron, okay, there are total n electrons. So total charge will be equal to n times of E. Number of electrons into charge of one electron. This E indicates the charge of electron. Okay, so Q is equal to Ne. This is the equation for net charge. So this one we can substitute here. Then here you will get Ne divided by T. So this is the second equation for current. I is equal to Ne divided by T. So based on these two equations, this is the first equation and this is the second equation. Based on these two, our numericals are weighting. So remember and also understand why we took here Q is equal to Ne, because n, we are imagining n electrons are flowing, then total charge is equal to n times of E. So this is the concept behind the flow of current. Look at this, okay, 1 coulomb charge is flowing, 1 coulomb charge is flowing. At the same time, 1 second we are considering, 1 second. 1 coulomb charge is flowing for 1 second. Okay, then what will be the current here? So this current, that is equal to 1 coulomb divided by 1 second. Then that will end up in 1. Current unit is ampere, indicating by capital letter A. So 1 ampere. This is the second point to remember. Define 1 ampere, or otherwise define the unit of electric current. 1 ampere is the current constituted by 1 coulomb charge in 1 second. This is frequently asking question. Define 1 ampere. This is a large unit. If we are taking very minute amount of current, at that moment we will go for milliampere and microampere. Milliampere and microampere. 1 milliampere, that is equal to 10 raised to minus 3 ampere. Okay, that means 1 ampere if you divide by 1000, that is called a 1 milliampere. Okay, then microampere. Microampere means 10 raised to minus 6 ampere. That also you should keep in mind. The device used for measuring electric current, that is called ammeter. That is always connected in series. What is series connection? N to N connection. That more detailedly we can discuss in the coming portions. Okay, so here you just remember ammeter is always connected in series. Just I can show you just here. Look here, 1 ammeter. This is the representation, right? So this, like this, to the end of the conductor you will connect the ammeter. Okay, ammeter is connecting N to end. Okay, N to end, this connection is called a series connection. Why we are connecting here? Because we want the measure of electric current, the magnitude of electric current. We already mentioned electric current or magnitude of electric current, that is the rate of change of charge. It is completely depending upon charge. Okay, so if you connect end to end, then this all electrons, that means the charges, all electron will pass through this. Then we will get exact measurement of number of electrons here. So that's why we want to connect it is a series. Okay, then only all the electron can pass through this, or all the charges can pass through this. One more point, its resistance is too low. Resistance, that word just keep in mind, that we can discuss in coming sessions. Today's session we can wind up here. We have discussed very fundamental ideas about electricity today. So let's meet in another session with another topic. Till then, bye.